So, hello everyone. My name is Carlos Rollo. I'm going to talk about automating data pipelines in the Google Clouds. And let's start. Who am I? So, I'm a part of the open source consulting team in Python, cloud architect, open source consultant. It's pretty wide. So I'm really like a Cassandra guy. That's really I'm all into distributed systems, but yeah, I really like it's Cassandra. Some programming, some systems, DBA. Can follow me on Twitter. Tend to tweet mostly about these topics. Okay, so about Python, I think you'll see these different versions of this slide today. So managed services, consulting, project, we have 20 years of expertise, we have 500 experts all over the world, around 12,000 managed systems. We love databases, Oracle, MySQL, Cassandra, MySQL, MariaDB, the cloud-based ones. We also love the cloud in all the flavors, in all the flavors, Azure, GCP, AWS, Oracle right now as well. So wherever you have data, we take care of it and we do our best. So what I'm going to talk about. So the first thing is what actually is a data pipeline and why do we need them? Why should we use them? And then I'm going to go how GCP allows and enables these data pipelines to exist in their cloud. And how do you build them? It's not about having them enabled, it's all about which tools I use and how to build them. And of course, automation, because if you want this to be automated, we need automation in place. And then I'll go out to fully automate a data pipeline in GCP and all the challenges found. So this is a new topic for recent topic for me. I've been mostly doing Cassandra and GCP being the last 1.5 years really deep into GCP, and data pipelines start to be part of my day-to-day. And automation of them was a critical part of it. So trying to do my best to explain what I faced and how I see the importance of this. So what actually is data pipeline? So everyone is talking about this lately. So we have a source, can be a database, can be a text file, can be whatever. We have an application delivering data, mobile device. We ingest this data and into some system, a queuing system normally. You can push this into a database as well. And then we storage and we process and we serve this data and visualize this data. And this is not something new. This exists for a couple of time. ETL process are a kind of data pipeline. We're just transforming the data, and so that's one of the reporting engines. All that kind of build their pipelines. So I have all slides in duplicate. I don't know what's happening. So pipelines are basically two types: the batch pipelines and the streaming pipelines. The batch pipelines are keen to use Hadoop, so you build your own MapReduce programs and they execute with the data you have there. And the streaming pipelines are more akin to Spark. Although Spark does batch, Spark streaming is now it's being more what's used lately. So streaming is data that's incoming and you don't have actually an ending stream. So you have like, for example, mobile devices, IoT devices, this kind of stuff that constantly feeds data into the system, and you never have a time where it ends. So you have to keep processing this data. You can also use both. You can mix and match them, and that's also, yeah. So it seems that something is wrong with PowerPoint. So what we need to build this data pipeline, what things we are that we actually know about them. So we have our data sources again, which can be whatever, can even be already a database. And these are some examples of data ingesting systems. Kafka is a good one, is known. Data storage can be Cassandra, MySQL. Data processing can be Spark or Hadoop. Data serving can be a database again. I'm just using Elastic to say another technology. Normally, especially since I'm coming from Cassandra, Cassandra tends to be a hard customer for visualization tools. So Elastic is something that we put in the pipelines to allow that. And then Kibana, for example, is an example of visualization tool. And why? Why do we want this? Well, everyone is talking about it. Everyone wants to do this. And data is no longer static. Data is changing constantly. You want to do more with your data. You want to extract more information. You need to enrich your data. It also allows parallel processing. So you can build one pipeline and keep extending it, adding more sources, adding more processing facilities, visualization in different ways, and it allows flexibility as well. So you want to move your data to different data stores. You want to feed data into another system that might not even live on the same cloud. So a data pipeline allows you to do this. But it's not for free. Nothing is for free. So there's a couple of important challenges when we are building these data pipelines. The first one, lineage, data lineage, is something that's really recent to me, and there's a problem that I didn't foresee. Is as our pipelines grow, as our data is transitioning into multiple systems, did I lose data? Where did my data go? If I need to backtrack this, how did my data get somewhere? We get to a place that our data is being handled by multiple systems that are not managed by a single person at some point. So you have MySQL DBAs on MySQL, you have Cassandra DBAs on Cassandra, you have people programming your data flows, you have people taking care of your ingestion mechanisms. And you have to make sure that you don't lose data and that you can backtrack where your data was. This also brings the second problem around permissions and security, GDPR. So you need to track your data, and you need to make sure that the only systems that can read your data are the ones that must read that data, and not more or less, especially if you're taking care of healthcare, financial data. This is important thing to take in account. You might need to anonymize data in certain steps of the pipeline. You might take some data out. So take this in performance. Why is performance a problem? Because as the complexity increases, you need to tweak all the systems to give a consistent performance out of the full thing. And it's not an easy task. Like I said, you might have MySQL, Cassandra, Hadoop, Spark, everything thrown into the mix, and now you have to make sure that your data flows are actually fast and you process the data in at least in the time that business says it's reasonable. And so performance starts to be a multi-layered problem. And another thing is replayability. You made a mistake. Everyone makes some mistakes. There's some mistakes in the data. There's something wrong even on ingestion process. You want to reprocess all of this. So you have to bake replayability into your pipelines. there's a new process, there's something that was wrong. You want to get back and redo what you've done. So it's data preparation. So this is all nice and talking about data pipelines, and I have multiple systems getting into this data and how this works with multiple databases, how the schemas match. So yeah, you have to prepare the data for all those things, all those systems. They read the data in different ways. The data needs to be prepared for them. An example is you read data from Cassandra and you feed into BigQuery. It's not going to work directly. So you need to prepare to have steps in your data pipelines for preparing the data for the systems that's going to get it. And of course, debugging. You have a mistake. You have a problem. Where is the problem? How many systems are involved? How complex this is? So, to give you power, flexibility, and data enrichment capabilities, you still have to think there's a lot of problems associated with that this doesn't get here for free. So this is an example taken from Google itself of a complex event processing. And as you see how many technologies are involved here, PubSub, Compute Engine, Dataflow, Data Lab, BigQuery, Compute Engine, Bigtable, and all them joined together through some kind of magic glue, like those blue lines, and they end up where you want them. So the problem again is, should all data go everywhere? How do I debug a problem in this? Where is my error if I don't visualize the correct data? So someone gets a mistake on the reporting and you need to trace all this back into this system to figure out where you are. Also, if you have some problem somewhere, performance problem, your reports are not getting out time. So of course there are simple models and simple pipelines, but what I've seen is once you start to build it, you'll get to something like that pretty fast. You'll start to want more and more and more out of your system. And so for an example, you have 1, 2 data stores here. You have computing engines as feeding and computing and App Engine as a receiver. So it's not as easy as it's talked about. I tend to be really pragmatic on this cloud thing. So when we map this to GCP, and we've seen that diagram, is what does GCP, why GCP? Why are we, well, it can be AWS, can be anything, can be Azure. But my experience, and this is my own opinion, I see GCP as a data first platform. It's not, AWS seems more a compute. They are moving all into this, but it seems that Google was the first to get this view. So it got a lot of things right. PubSub as an ingestion system is really powerful. Bigtable, BigQuery as a storage. Data processing, you have Dataflow and Dataproc. Data serving, you can use BigQuery and BigQuery Analytics. You can do visualization on Data Studio and Cloud Data Lab. So all these are tools. I think I forgot about data prep, and also as data catalog to allow you on anonymization, protection of your data, data lineage. So Google has some really solid tools on this topic of the data pipelines. Again, so these are all the offerings Google at the moment has for integration into pipelines. So you can ingest from anywhere. You can Cloud PubSub. The storage is there's a massive diagram on Google how to pick your storage for what you need your storage. And you should follow it because they are actually offer a lot of different options, and on a data pipeline, given the speed of your pipeline, you probably will get into using several of them. Normally you want this to end in BigQuery because you want to move into visualization and analytics, but if you have fast data, you probably want Bigtable. And then you do a second pipeline to feed BigQuery. If you want structured data, you need Cloud SQL. So it's mobile stuff, Firebase and Firestore. And process analysis, so Cloud Data Flow is at the moment the go-to technology into Google. So I'll talk a bit about it later. You have Dataproc, BigQuery, CloudML, and the Visions, all the APIs, the data prep. No, Video Intelligence is new. And of course, Data Lab, Google Studio, and you can always build your own. That's the thing. You can always connect this to Cloud Engine, Compute Engine. Have your own tools. Roll your own Spark. Roll your own Hadoop. Roll your own custom code. Connect into any of these services, and go from there. So automation. Automation is all about Terraform. In this, there's a new version, 0.12. I want to do a demo, but 0.12 broke it, and it was actually on top of time to actually revert stuff. It changes some parts, so it's way better now, finally. So if you're not into Terraform, 0.12 is a really good release to get into it. If you are on Terraform already, well, you need to adapt to the new version. It's descriptive, it's based on HCL. This is the way, for example, you create topics on PubSub. It really simplifies, it's really simple. Most of the Terraform APIs for Google are simple to use. You see, this is create a lot of topics on PubSub. So you have to have in this kind and feeding data through PubSub to BigQuery. The only problem in Terraform and GCP is IAM, and that's the kind of elephant in the room. I will go through that later also. So how do we build this into Dataflow and PubSub? Into GCP, sorry. It's all about these two technologies. It's all about Dataflow and PubSub mostly. You can use whatever, but you'll see that you land on these two technologies most of the time. They do have limitations. They are not silver bullet. They will not fix all your problems. They might even bring you some extra ones. So let's start with PubSub. I love marketing and the way they make this happen. At least once delivery, say, okay, you guarantee that you get your events, but you also might get them several times. So take care of that when you think about managing PubSub. Well, it's open, but it's not actually open source. You cannot look into the code. So if things get wrong, well, you have to hope that someone had their mistake. Global by default, it seems like a really, really nice feature. It means you have also a really, really nice latency. So if you're consuming stuff from PubSub in other parts of the globe, it does, well, data does not go faster just because Google says it's global by default. Compliance and security, it means that your IAM must be get right, or otherwise you have no permissions to read, publish data. Does bring something really good, seek and replay. You can actually replay your data. It auto scales. So you get all those things. It's really, really well integrated with everything Google. So almost, actually, I'm not saying everything because I didn't try everything. But I have yet to find some piece of GCP that does not read or write to PubSub. So it's like even Gmail, so, and calendar. You can do whatever you want with this. It's really good. If you want to test it, throw some files in Google Cloud Storage, and you see that PubSub can read from it, and then you can consume it somewhere else. So that's it's really easy to start with PubSub. The other one is Dataflow. Dataflow is a kind of magic data processing engine, but it's not that magic. So first of all, my biggest pain with Dataflow is Dataflow is akin to Airflow. It uses Apache Beam SDK. It uses, so it's a kind of MapReduce processing engine. It doesn't support, how many languages they say they support? Oh, they say they support a lot, like 7 or so. But if you really want to work really well with this, you need to go Java. That's the thing. Python works as well as long as you don't write to BigQuery, for example. So you have to really go into documentation before, especially if your programming language is not the one, it's not Java. So if you are into that, if you are into Java, Dataflow is perfect. If you're not into Java, read the documentation carefully, because the other language do not have the same level of support, does not offer the same level of integration as PubSub, but well, it integrates with PubSub, so you can always push stuff into PubSub and from PubSub into Dataflow. It does auto scaling, it does resource management, all that managed for you kind of stuff. It's reliable, it does stream, it does batching, so you can do whatever type of processing you want. And it can get really complex. So Dataflow depends on your code, of course. It's your code. So you can forget these two things. It's like GCP does not mandate to you to use that. You can deploy your own, or you can use other stuff available from Google, like Datapro, Cloud Functions, App Engine, and roll your own stuff. So don't be locked into those two if you don't want to, especially if you want to later move your pipelines somewhere else. But if you think you're going to stay in GCP for a while, do leverage those. They will greatly improve your life. So, like I said, automating is all about Terraform. Terraform is easy. You get your GCP provider, use a Google storage as the state provider, by the way. So if several people are doing Terraform, the state is consistent across multiple teams and people. That's a key finding. Well, the big problem is IAM. IAM is the, like I said before, the elephant in the room. It's really difficult to get IAM correctly in GCP. It's so fine-grained that you tend, and it's hierarchical, so it tends to be messy. Found out recently that we are having problems with permissions because someone was deleting a BigQuery dataset and recreating, and the recreation will not edit the previous IAM thing, so we had to rework the way we did IAM for the project. This is not only for data pipelines. This IAM is a pain for everything automated in GCP. So it's It's I think the steepest learning process in all GCP is dealing with IAM. Of course, we can always go everyone owns everything, but that's not the way to go. Zero trust is a better way, but it brings its problems. But there's a problem here. Terraform is not ideal for code deployment, and data flow is based on your code. So you want to run your code. So how will you go into a full automated pipeline, including deploying your code every time you change? You can use Terraform. Terraform will deploy your PubSub. Terraform will deploy, will create your data stores, will do the glue between them, create topics and all that, but you need your code. And this is where things get complex. So you have two options. You deploy your code manually, or you integrate your code into your automation. And this is a way to integrate using GCP as well. So you can create a code pipeline. And this is literally a pipeline to deploy codes into the recommended pipeline to deploy code into Dataflow. So you create a source repository, you put your Dataflow code there, it will trigger a Cloud Composer which will build your pipelines and then create your jar files, push and deploy, well, if you and test, if you build the tests. And the tests pass, it triggers the thing and deploys your production pipeline. So what is the biggest problem here is actually getting this right, first of all. And if you have a bug, your bug goes automatically into production and your fully working pipeline goes crashing and burning and you have a problem to deal with. So automation is really nice, but well, if you make a mistake in a massive automated process, you have some serious trouble to handle it. So my experience is automate the infrastructure, do not automate so much, or do not tightly integrate all the automations. You don't want a chain reaction because a bug was somewhere. The tests are only as good as you write them as well. So it's not like, yeah, the code is tested. Yeah, how good are your tests as well? How much test coverage do you have? So I've seen a container break a Kubernetes cluster. Well, I did it. So because I had a bug in somewhere in the Python code. So it's not... these things are all nice, and we get the idea that we can have a commit and then we extended our pipeline magically to deal with whatever constraints that business got into us in a easy fashion. Well, we can also do the opposite. We can completely break what we already had. So that's why they said, yeah, you can trigger the test pipeline, put this in the test bucket, but I also recommend to actually separate those two steps. You deploy your test infra, and that's the really good thing with automation is deploy your test pipeline, deploy your test code, and do Terraform destroy once you are happy with the results. And you push that to production, and you go into production. This looks really good on paper, but I think that's where it should, unless you went into such a level of confidence in your tests that you can literally use it that way. So, like I was saying, you should Terraform your infra. You can also Terraform that previous pipeline, so you can Terraform your CI/CD pipeline if you need to change it. Terraform you can create for another team, another development team. External consultants get access to what you're doing. You just, yeah, this Terraform, build your own project and test it there. CI/CD your code. That's the advantage of terraforming your CI/CD is you can give all this to other people to test the code, even externals, and everything should is a nice word. There's always something that you don't understand. You go there, especially IAM, and you forget about the IAM, and then people don't have permissions anymore. So that's the. So a couple of takeaways. Well, I spoke a bit fast. Is that pipelines allow you to have a lot of flexibility on your data processing. Typically, we will do ETL the old-fashioned way. That still works perfectly fine. That you write your own scripts and you run those against the database, and things get transformed and loaded somewhere else. If you design a pipeline, well, at least the first steps are similar for whatever, for your ETL and for whatever process you do on your data visualization. For me, this was advancement. It was something that was really good, because Cassandra is really bad on the read side if you do some stuff wrong. So having a pipeline to push the data in something that handles BI really well, and then I can change to whatever is there, was a positive step. And once it's there, and you will extend it, and you will improve it, and you'll see start that you don't need to be that, how do I connect to the database? You have or what is even the database? It's not even a problem anymore. Allows your data to move around. But all this might make you lose track of your data, and lineage becomes an important thing to solve. Security, GDPR for us here in Europe is like, how do I delete data that is, where is my data? Then I need to delete it, I need to anonymize. So encryption, running your own encryption keys, encrypt part of the data, other is not relevant. So Google also allows, most of these tools do have integration for encryption and encryption sets of data. In GCP, PubSub and Dataflow are first-class citizens, and they probably will be the big enablers of your pipelines. And as well, you probably concentrate a lot of your effort specifically on Dataflow. And you will need a CI/CD process for your code. This is something that I was not really into, and then I start to see the light. Now it's especially the because like I said, it automates all the stuff. You don't need to compile and this and that. You just commit your code. You set a trigger on a tag, and once that tag is committed, you will see that things start moving. And once you get the handle of it, you suddenly start to see, okay, so committed 10 lines of code, and I built a new pipeline, and my data is moving from A to B to C to D, because the things were really well done. And in the end of the day, I can destroy all this because I was just testing, and the next day I do a command and this is all up again. So it reduces costs, and well, then the point of failure is like, who knows the automation? So who automated this? If there is a bug, well, the debugging is an issue. So I was a bit fast on time. Still have 10 minutes to go, but well, any questions? Any? Otherwise, yes.
Excuse me. Did you speak about the PubSub? No?
Yeah.
What is your recommendation, or I don't know, your experience about the how type of message we can send into the PubSub?
PubSub can eat almost everything. That's the thing.
But for example, queries into the database.
Yeah, so that's the problem. So you didn't need someone that reads from PubSub and do the queries. So, well, if you integrate with the Google databases, you can read, you can get stuff into PubSub once the database changes, but you cannot query the database from PubSub directly, as far as I know. So you do have to, for example, have App Engine or a Cloud Function doing that for you. Like you get this type of message, you do the query, and then the result is transported somewhere else. So that would be, if it's something that you are not constantly doing, I would do a Cloud Function most of the cases. Beware that Cloud Functions are wide open, as in you cannot securely close to the exterior Cloud Function. So that's a big no-no if you're dealing with important data. In that case, you have to run into App Engine, but then you need to write a small program that knows how to read from PubSub, do whatever you want to do with. So you will do a parser anyway, somewhere in the way. There's no, as far as I know, no automated way for PubSub. Like I said, it looks like magic in the first diagram. If I go all the way, where can I see this? No, it doesn't appear here. So this one. So yeah, so you see that it goes from data flow. Well, actually here everything goes from, for example, big table to data flow is like the streaming engines are reading. You cannot you can connect PubSub directly to the databases, but you should always have something in or data flow. But yeah, you cannot query directly. There's not an option, as far as I know.
Because maybe you lose the consistency in the transactions.
Then so that's one of the things, is like you need to track your data. That's the biggest problem here, is you need to track your data, and you need to track if the changes actually happen. That's a good question, is if something of this fails in the middle, what should I do? So then why replayability is an important thing, like I said. That's all true, and that might happen, and that it's not might, it happens. So you need to be sure to track your data and to build replayability into this, because that is indeed a problem. And by the way, PubSub allows replayability, but and another thing I didn't talk about is Stackdriver, but that's something like off the pipeline. Stackdriver will log stuff. And normally what you do is, once Stackdriver starts logging stuff, you start creating a second pipeline that will redo whatever Stackdriver is telling you that's wrong. So, or you just put it somewhere in a bucket and then go after with what's in the bucket. Any other questions? Okay, thanks everyone.